Hi, everyone. My name is Pete Scheldenbrand. I'm an application engineer at Siemens. And today we're going to be talking about SimCenter Test Lab displays. And our presenter, Scott McDonald. Would you like to introduce yourself, Scott?
Sure. Thanks, Pete. My name's Scott McDonald, and I'm also an application engineer at Siemens. And we're going to be talking about displays today.
Thanks, Scott, and take it away.
All right. Thanks, Pete. We're going to be talking about the displays in SimCenter Test Lab today. And I thought I'd start with some real basic overview, just cover all the types of displays that are available in Test Lab now. And then if you are brand new, I'll just show you briefly how we create a display and add some data to it. If you've never done that before, you'll know after today. And then some other basic stuff, things like duplicating a display. If you've got one that looks like what you want and you want to maybe create a sister plot or something, I'm going to show you how to just duplicate that display. And then as a fundamental aspect of Test Lab displays, I'll bring up active pictures, which is a key feature for us. Then the middle agenda item there is the display options. We'll talk about some different things that are a little bit hidden in the software, so maybe you're familiar with them, maybe not. We'll go over the things listed here. And then we'll close by talking about creating a custom display and using what we call layout management within Test Lab. We'll start with some display basics. So just to talk about all the different types of displays, I've got 3 pages of these, so we'll just cover these all briefly, but probably the most famous of Test Lab displays is maybe the front back, and this is really just a typical XY plot where we can plot data on maybe 2 different Y-axes. So microphone pressure versus time, as well as acceleration versus time. We could do that with 2 different units on the Y-axis with the front back. A Bode plot's going to show us an FRF in magnitude and phase, or real and imaginary. Upper lower is just what it sounds like. Multi-trace is where I like to plot time data or throughput data, and there's some neat features there. Nyquist is also a real versus imaginary plot, but it shows you a rotated view where you would see an FRF and you would see them in actual circles in that format. XY is for things like suspension travel, where you have things varying both with X and Y that isn't a traditional front-back type display. Octave displays specifically for third octave or whole octave. Acoustic data typically. A color map and a waterfall are partner displays. The color map is really just a bird's eye view of a waterfall being a 3D map of a frequency spectrum or something, amplitude versus frequency, and then versus some other tracking parameter, maybe time or RPM. Same with the color map there. Numerical, just like what it sounds like, you just want to output a speed or something, very useful. Geometry, great for looking at mode shapes and test geometry. Matrix heat map is relatively new. If you have a big set of FRFs, you can dump all kinds of data into a matrix heat map and you'll see it displayed as you see there on the screen. And it makes it very easy and quick to compare large families of FRFs, do a coherence check, and immediately see if you have something wrong in your data. The matrix
some of
here,
these displays, Scott, appeal to certain demographics, like on the previous slide there, the numerical, does that appeal to management types who just need everything to be a single number, or is the other ones are a little more engineering?
yes, and with the numerical for management, we actually take out those significant digits, so it would just be like 75 here.
Yeah, I noticed it has a color too, like green or red. Good, or that probably helps interpret the number.
Particularly for management, yep. A matrix, this is like a durability processing, rainflow matrix, dedicated display. Point cloud is where we can plot RPM versus load versus amplitude and pressure, so you can actually map out several runs of data and fill out this point cloud. Orbit plot, very good for doing shaft centerline plots where you're looking for vibration or displacement on a bearing for a shaft, as well as polar plots. This is a rotating machinery. Essentially, if you're doing rotating shafts, you might want to look at a polar plot. The GPS display has been updated to be a full map display. So now if you drop in some GPS latitude and longitude information from your GPS on your SCADAS, we'll actually go out and pull up the Google Maps info for you. And so you can see where your data was on a full color map now. And then in Test Lab Neo, we also have this video sync where we can bring in video taken from any camera and actually sync it up with any time domain data, so impacts or vibration or anything like that. So that's the full suite of types of displays. Now I'm just going to touch real briefly on how to create a display and add some data. So if you're brand new to TestLab, this is the GUI here. And the first thing we'd like to point out is this list of display type favorites. So if you get used to using certain types of displays over and over, you can put them up here in your favorites and just have ready access to it. This part under create a picture, we will talk about this a little bit later today. This is if you want to create a custom display, and you can also add that to your favorites. We'll talk about that in just a bit here. So first, step one is find the folder with your data in it. This will be in your project or somewhere else on your computer. Click on that folder. The data in that folder will then appear in the middle pane there. And so we see an FRF, and then we can just click and drag and drop that FRF onto a display. And that's how we view our data. So we're doing some dragging and dropping. When we locate our data, we just drag and drop it into a display. And there's some advanced options we'll cover if I want to replace or update the data in a display as well. So duplicating displays and active pictures. So real simply, if I've got a display here in TestLab and this FRF looks like what I want, I can go up here and you notice I've got several different types of displays up here and they have their own tabs. But I also see this little down triangle on my front back that I have here. And if I click on that, I get some interesting options, one of which is rename. So if I've got a bunch of plots, I might want to rename this to be FRF front or something like that. If I'm comparing FRFs from different areas of a vehicle or structure, I can certainly rename it to be something a little bit more useful for me. I can also duplicate this display and it will do just what it sounds like, and I get another copy. So we see these two identical displays. And then I can also delete and delete all. And there's some other additional options here, one of which is this copy as active picture. So I'm going to do that. So if I just want to plot this data into a PowerPoint presentation or something, I can certainly copy it as a picture, as a bitmap or a meta file, and it will just be a static image. If I just need to communicate this information from this plot to a colleague or something, I can just copy it as a bitmap and it will be as you see it, fixed for all time. However, a little bit more flexible and powerful method of doing that same thing is copying as active picture. So if I copy as active picture and then I go back to, let's say, my presentation here, and I'm gonna create a new slide and I'll get all this other stuff out of the way. And now I'm gonna paste this as an active picture. What an active picture allows me to do is, with a free plugin from our website, I can now double click on this active picture and I can do all the kinds of stuff that I would normally need TestLab to be able to do. I'm able to do this right inside PowerPoint, and I don't need a license of TestLab. So if I've emailed this to my boss or someone in another company who doesn't even have TestLab, they're still able to come in here and investigate, okay, what frequency is this second peak? Okay, it looks like it's around 250 Hertz. All of this type of stuff they can do right from the PowerPoint active picture with that free plugin. So it's very, very flexible and powerful. Let's say I've created this picture and now I want to change the axis or the format and put it into dB. I can do that, whereas if I just copied it as a picture, I'd have to go back to TestLab, open up my project, find that data, replot it, change it, and then export a picture again. Whereas with an active picture, I can do all of that right here in my PowerPoint.
You know what I find pretty cool about active pictures, Scott? Is just throw you something spontaneously here. When you double click there, you can do data properties on the curve, and you can actually get information about how it was acquired, like the sensitivity value, the sampling rate, all that kind of stuff is also stored in there. So if I'm looking at some weird piece of data, I'm not sure how it was processed or if the cal value was right, I can actually double check it, the active picture. I think that's pretty useful too.
Very useful.
Data properties.
I, of course, never make testing mistakes, so I've never even considered needing that feature, but
I need it like every day, about once an hour at least.
Yeah. I bet. So this recovers, some of those options under this display drop-down menu up here. I can rename, duplicate, or delete an individual display. I also have these copy as picture or active picture options. I can also do some more advanced things, which we'll touch on in just a little bit, like replace data origin and set coupled limits, which we'll cover as well. So that takes us into some of the display options we have at our disposal. First up, I'm going to show you something called a detached display, and I'm going to use this in concert with something called a processing cursor. And this was something that when I was a user of TestLab before I worked for Siemens, I did not know about, and so I find it particularly useful to bring up. So let's say I'm working on an engine or something and I've measured acoustic pressure versus RPM. So I've got this waterfall plot here, or a color map rather, and I'm looking at that frequency spectra versus that RPM sweep. I definitely see some interesting things along the orders and things, but I want to take a little bit closer look. I'm going to go up here to this little icon in the upper right, and it looks like a little plot with a little yellow starburst on it. If I click that, you notice I get this floating window here, and it looks just like TestLab does when I start. It says, how do I display data? I can create a display here. So in this case, I'm going to create a front back. And so now I have this extra window that isn't attached to or fixed inside my TestLab. So I've got a separate monitor or something. I could put this over here. And I'm just going to display some data on here, but in order to do that, I'm going to come back to my color map. I'm going to right click and say add a processing cursor. In this case, I want to investigate some of these diagonal lines, these orders here. So I'm going to add an order cursor. And you notice I get this other floating window with a little piece of data sticking up here. I can now drag and drop this right into that detached display. And what that is now the order cut along this processing order cursor. So as I move this through my color map, my detached display will update. So this makes it very, very convenient for me to view not only the overall color map of all sound versus frequency and RPM, but now I can say, all right, I know we're battling an issue on order 12.5. And so I can send that right to 12.5. I can add a second processing cursor, another order, and I can drag that guy in here. And this other one I'm going to send to, so I double click right on that cursor and I can send it to, let's say, 6th order. And now I can compare 6th order versus 12.5 order right here in this display without having to cut these orders separately or create another display or stop looking at my color map. I can look at these individually, and maybe I say, oh, it's not 6th order that I want to compare to, it's actually 7.5, and so I can just move this other cursor and immediately see the difference between 12.5 and 7.5 order. So that's a detached display, one of my favorite options.
I was going to say sweet, but sound immature if I did that.
Yeah, we'll go back and cut that out of the recording. Now we're going to talk about some access options. We want to tweak these displays that I've got, and I'm going to show you some other things that you can do within some of these displays. So I'm going to close this. Warns me that I'm going to lose my data there. That's fine. So I'm going to go to this plot, and I've got a couple of order cuts cut here, and I'm comparing them. So I've got RPM on the x-axis and amplitude of vibration on the y-axis. And certainly in any part of my display, I can right click and you'll see I get this little title up here. It tells me I'm about to change some options for my x-axis. I can certainly change my limits. Free means it's going to go literally to the data value. So you see this odd number here, 4033.4 RPM. My lowest value is 1545.3. Those are exact data points that I have. If I put this on optimize, it will make this nice round numbers to start and stop. So you see my data starts a little bit inside the limits of the plot now. Maybe that's how I like to do it. Other option here is fixed. So here's where I literally want to plot from 1100 to 40, 50 or something, and it will do exactly what I want. I can also get to the limits fixed by double clicking on the axis, and I get that same dialog box there. So those are some limit options. Same thing happens if I go over to the Y axis. I'm going to put these back on optimize just so we can see the whole plot here. On the Y axis, I have these limit options here as well, and I'll leave those as optimized. I also have some other things like format. So you notice I've got it currently in decibels. I could also plot this in amplitude. So now I'm seeing just in straight linear G's of amplitude of acceleration. I can put this, if I wanted to look at this in real, where it'll be both positive and negative. So it takes into the account the phase of my order cut there. In this case, I'll look at it in decibels. And I have some other things here I can do, like unit. I can default is G's of acceleration. I can also instantly look at this same information, but show me acceleration in meters per second squared just by clicking on unit. And now the values on the axis update, and this same information has been converted to meters per second squared. And this is all managed by the units manager for SimCenter, and that runs as a separate application where you can control all of these units and control what units display here and which you'd like to be your default. And in addition to that, I can also do some interesting things like processing, where if I go highlight under this processing menu, I can certainly apply some weighting. So we have A and B weighting. I can also specify always show it to me in linear or the original, how it was recorded. Under more, you see I have also C and D weighting, as well as some human body vibration weighting factors for how sensitive we are to vibration in the hands and arms and whole body. So I can apply some weighting here. I can also do some interesting things because I'm in the frequency domain. I can very easily double integrate this acceleration and get it in displacement versus RPM. I can take an acceleration measurement using an accelerometer, double integrate that. I'll go from acceleration to velocity. That's one integration, and the second integration will get me back to displacement. And I can do the same thing. So if I started with displacement, I can actually differentiate those to velocity as well as acceleration. If I say none, I'm going to go back to how it was measured, which is G's of acceleration. Some other things I can do here is hatching, which I'll show you. There's another processing thing I'm going to show you, but I'll come back to that. This is very useful. Let's say I've got blue is our original Model 1, if you want to say, and green is the new prototype, and we want to just compare, did it get better or worse? You can go, obviously you can see this, but one of the nice things that you can do with clicking on the y-axis is hatching. And I can just real quickly add some hatching to the plot. So now anywhere where the green is higher amplitude than the blue, it gets cross-hatched in green, and then vice versa, where blue is above green, I get this nice blue cross-hatching. I can view it as hatched, or I can actually make it solid, so it's even more obvious. This will always work for the first two traces in a plot. So if I had 4 traces in this plot, it would really only hatch between the first 2. So just keep that in mind. So that's a nice display thing. One of the other things I can do is under this processing menu is I can do something called smoothing. You see this section down here. And I'm going to add a cursor here just to show you how this works and one of the nice features here. So I'm going to do a cross at the Y. And I'm just going to pick one of these local maxima here. So I want you to keep this value at 2661 RPM. I've got a value right around 50.5.
And the idea of the smoothing, Scott, that again, a manager can't handle all that hashiness, or they focus in on that and they kind of forget the overall trend.
Exactly, right. So this might, to an uneducated, or I shouldn't say uneducated, I should say otherwise occupied person, you might see all these peaks in here and think, are these all resonances? What's going on? And so you want to maybe smooth some of that out. I can go to this smoothing portion here. I can just apply some nice linear smoothing. And you see right away the jaggedness of the trace is reduced, but you notice I have a reduction in amplitude here. Okay, so that cross cursor didn't move. So I can come in here and I can go to smoothing. I can also do some exponential where we have light, medium, and heavy. And if I apply heavy smoothing, you see it gets even smoother, but I have a significant drop in amplitude. So if I'm really concerned about the amplitude of this order cut, this may not be a good solution for me, but that's why we have this additional option in here where under smoothing, I can keep the peaks here. I can set the number of cycles for the smoothing. So if I do 1 cycle, it's very close to as if I didn't smooth it. It's just a real low level of smoothing. If I increase this to 10, it's similar to adding a heavier amount of smoothing, but I'm going to keep my peaks. So you notice the amplitude here, even if I go all the way up to 100, the amplitude at that RPM is exactly the same. I'm able to, the algorithm that we use to smooth this data keeps the peak values and those stay the same, and all the minima of the jaggedness are sort of smoothed up to those peaks. So I can always trust the amplitude values, even if I'm applying a heavy amount of smoothing. This is way more smoothing than I would, for all intents and purposes, ever really apply, but something like 10, maybe that's pretty reasonable. You can see some of the nice undulation in the curve, but it's a little bit cleaner to look at, but I can trust this value of the local maxima because I've used that keep peaks option. So hopefully you see replace data in a display is highlighted as our next topic. So I'm going to go back to TestLab here. And let's say I've got this display where I'm comparing second order, fourth order, and sixth order for a body mount. Second order, fourth order, sixth order for run 1 versus run 2, as well as an overall level. And this is great, but I also took a third run of data, so maybe I want to compare run 1 to run 3. I could certainly go through here and remove all of the run 2 manually, click on this guy, right click and hit remove, etc. Or I could rebuild this plot from scratch if I really wanted to, but there's a better way for cases like this, and I'm going to use that display down arrow and I'm going to go to that replace data origin we were talking about. So here it brings up this menu where I can say, do I want to replace the data on a project level, a section level, a run, or an actual measurement cycle level? In this case, I want to change run 2 to run 3 and compare those two, 1 and 3 together. So I'm going to swap out my measurement cycle. I'm going to browse to this guy. You see it's currently looking in run 2, so I'm going to go up a level. I'm going to go now to my run 3 folder and into my fixed sampling folder there. And so now you see it says run 1 versus run 3. I hit apply and all of my data is updated all in one go. So if I've taken the same exact data in 3 different runs and I just want to quickly display different runs and I've got 1 versus 2 plotted, I can quickly swap out wholesale run for run very, very easily. Another option I'll show you just for fun. So this is second order mount right on the body for run 3. I'm going to go in here and I'm going to click on run 2 folder under my orders. And I can grab, let's say, this guy, second order. This is now run 2, mount right body in the Z. And I can drag him over. And you notice if I plot it in here, it's going to add a third trace to this plot. But if I want to replace one of the 2, blue or the magenta that I've got here, all I have to do is just come up to the legend. And you notice now it's highlighting just one of those 2. Now I'm going to replace that guy, and so now you see it's run 2 in the magenta. I can do that with any piece of data. Obviously, it's a totally different location, and so the data is much, much less similar. But if I've got mostly what I want, I just want to replace 1 trace versus adding a third trace, which is what I do if I drop it in the main display area. So that is replace data. Now I'm going to talk about aligning displays, and we do this in a couple different ways, but this is where I've got multiple displays. I've got 3 different sections to this display, top, middle, and bottom. And again, I've got 3 different runs, and I'm comparing overall level between these three. And you notice I've got all kinds of differences here, right? It's not easy for me to compare these three runs because I've got way different limits up here. I'm going from 0 RPM up to 5,000, totally different numbers here for my x-axis. Again, x-axis is totally different here. Well, I can come up here and I can, again, go to that display pull-down menu and I can say coupled limits. And so now if I look over here, you'll see this check mark there. And now if I come in here and I say limits optimized, boom, now all three of these limits in this display are all coupled together and they all became optimized. So they're now all optimized to the appropriate value for that run. And you see it is a little bit different where run 1 is 4,100 is its maximum value. This one, run 2, I only got up to 4,000 RPM. So the data is a little bit different here. If that is a problem for me because I really want to ideally look line for line identically, I can come in here and I can say limits fixed and just say, show me 1,500 to 4,100. Boom, because they're coupled, now they'll all be coupled to exactly those values. So that's coupling the limits, and I can do that for a whole display all by just clicking this coupled limits. This companion to coupling limits, if I've got multiple plots I'm looking at the same time, is something called a coupled cursor. And if I right click in the white area of my plot, this is where I was adding those cursors before. We talked about the processing cursor and a single cursor where I did the cross. Now I'm going to add this coupled cursor. And if I do that, you see I get a couple options. It says RPM or Pascals. And this is what it's telling me is I'm going to give you a cursor. Do you want to be moving that cursor in Pascals in the amplitude or the y-axis or along the RPM axis? In this case, I'm going to choose RPM. So you noticed it added 3 cursors here, but they're all coupled together. So if I move in one, I move in all 3. Even if I come in here, I'm going to turn off my coupled limits and I'm going to zoom way in on this second plot. I'll do it even more in here. Even if I've got, they're no longer aligned, the cursors stay coupled together. So I'm always looking at exactly the same x-axis value, okay, with a coupled cursor. Very, very nice if I want to zoom in on something on one of my displays, but keep an overall view on the other display. It makes me certain that I'm looking at the same phenomenon per RPM value. Okay, so that's a coupled cursor. To supercharge that, we can use something called align the whole display. So in this case, I've got 4 plots here, and I've got all kinds of stuff that's different. So I wouldn't probably, I took extra effort to make it this different in terms of line types and colors and axes and everything else. But I'm going to show you how you can get to one-click, one-stop shop as far as clicks go. So I've got all these displays and they all have different options. I've got amplitude versus real, decibels over here. We've got different x-axes all over the place. This guy is even different in terms of the curve type. But let's say this red versus blue in the upper left is what I'm looking for. Okay, I'm looking for optimized x-axis. I'm looking for amplitude format in the y-axis, and I want it to look just like this. I can come in here and I can say, right-click on that, display format, and I can click this align front back display. So these are all front backs. I'm going to click this and it gives me an option menu here where I can choose what aspects of this plot that I clicked on up here I want to align to. Right now I'm just going to align the x-axis, the y-axis, the legend format, and the display option. So all the cursors and stuff that I've got in there. Right now I'm going to leave curve styles unchecked so that the colors and the curve styles will stay the same, but all of the axes and legends and everything else will be aligned to this top left guy. So if I hit apply here, boom, in one click, I get all of those changes are aligned to this guy. But you see the curve styles and colors and everything stayed the way they were. if I now come in here and say, oh, I changed my mind, I do want them all red versus blue, I just add that to the alignment and hit apply, and now I've got 4 fully aligned displays. So that's the one-stop shop. When you have a multi-display situation, you really only have to get one looking how you want and then align the rest of those displays to that guy. One other thing I'm going to show you before I leave here. This was another thing I didn't really know when I was just a user. And it happens very frequently when you have something like this, where you've got a color map versus maybe an individual frequency spectrum. This is one of the pieces of data that is part of this color map up here. You see this is a processing cursor, so I can align this to this different RPM trace. And I'd really like to be able to look at this plot up on the top and this plot on the bottom and know that the frequencies are aligned. So one way I can do that is I can add a coupled cursor and say in frequency, and now as I move, these will do the alignment for me. But just graphically, again, I'm going in front of Pete's boss, and I don't want to have him trying to do that mental gymnastics while I'm presenting. So I'm just going to align these displays myself. Because this color map has this color scale over here, this guy isn't quite as wide as the guy in the bottom. So I'm going to come over here to the edge of this guy, and I'm going to hold the control key, and I'm going to hold that down. And if I now move this axis, I can now resize this display however I want. Okay, so I'm just going to artificially create some white space over here. I'm going to do the same thing up here because you see how big I've got this amplitude format down here. I'm going to grab this color map, and it's not going to do it for me for some reason. There we go. I was just grabbing the wrong spot. And so now I can resize these two displays so that they're perfectly aligned. And now I see these peaks are perfectly aligned with these sort of resonances I see in my color map. I do that just by holding down the control key. So that's just a little bonus tip I'll throw in there.
Now that you did that, you need to set the frequency ranges top to bottom differently. Create the offset again. I'm joking.
Yes, right. Yes, exactly. And then finally, I'm going to show you how to change some curve styles. So I don't remember exactly what revision it was, but 12 or 14 or somewhere in there, we added some nice capability for curve styles. So if you see this plot, if you are normally dragging and dropping multiple curves into a test lab display, this color properties order will look familiar to you. The sort of default is red and then green and then blue, magenta, cyan, and then brown. This is where I end up with a default, but I'd really like it to be something a little bit more unique or helpful for me in whatever condition or situation I'm in. In this case, I just want it to be a little bit more visually appealing. And so I can go through here and I can certainly double click on any individual trace and change the color and the width or the thickness of the line, etc. I can do that one by one. And maybe that's how I created this. But now that I've got it done, I say, man, I really like this order where it goes red, orange, sort of tan, then green, then blue, then purple, sort of a rainbow color order here. I can now, without ever having to recreate this, I can now apply this curve property schema over and over. And I'll show you. If I right click on that curve and I go to curve styles, you see the way that I've got them set up is already shown here. But if I want to configure that scheme, I now see I've got those properties in the order that they show here. I can actually save this as a scheme, and you see I've got one called Rainbow. We'll call this Rainbow 2. And now I'll go over here. I'll say I want to apply this scheme. So I right click on the trace. I go to Curve Styles, Configure Scheme. I want to load one. It's got Rainbow or Rainbow 2. I'll say Load Rainbow 2. And now I can say Apply to Curves. And boom, I've got a plot color scheme I can apply every single time I want just by loading it and applying it all at once. if I go back to default and apply that to the curves, I can also do it this way where, let's say I didn't have this curve scheme saved. I can right click on here, go to configure scheme, and I can say load it right from the curves. So it would read these curves. Let's say I got this plot from someone else. I could load those in. I could then save it and then apply it to my other plot. I can also do this on sort of a one-by-one basis where I go over here and I want to load, let's say, rainbow. And now I've got rainbow loaded, and I want to come over here and I can just change that green to this green. And I can just apply it one by one because I've loaded that rainbow scheme. I can just sort of select one by one. So let's say for some reason I wanted blue and green to stick out. I can just apply those schemes on a curve by curve basis, or certainly go in here and apply the scheme all at once.
It's like you have a little palette, you're an artist, and you have your little color scheme or something.
Exactly.
Nice.
Yeah.
By the way, for calling it rainbow, now I have Kermit the Frog Rainbow Connection in my head.
Good. Well, that's good. I'm happy I can help. So that's the curve style. And now we're going to talk about the high end, if you will, the high power user, where I want to create some custom displays. And I'm going to use something called layout management to do that. So if I go back into TestLab, you notice I can certainly create any of my favorites up here just by clicking on this, and I'll get a brand new front back. I could then drag and drop some data in here and plot my data that way. But let's say I want to do something a little bit more sophisticated, or tired of adding this data over and over to a plot format. And I'm going to show you an example where, let's say I want to test to a target. Okay, so I know I'm going to go out and I'm going to test a vehicle or something, and I've got a target line, and I want to look at that data instantly versus a target. And so if I go in here and say I've got a project where I created some target lines and I throw that data point in here. So now I've got a decibel level versus RPM that my driver's ear is not supposed to exceed. Just because it's a target, I'm going to make that black line, and I'm going to add some width, say. This is front back, and I don't want to have to always find this targets project and go and drag and drop that data in there. So what I'm going to do here is I'm going to come up here and I'm going to say save as layout. And so you see, because I started with a front back display, it's going to say, let's call it front back. And I'm like, well, if I do that, every time I click this front back button, it's going to have this data be a part of that display. Okay, so anything I have in this display that I'm about to save as a layout will be included when I create a picture with that layout, including data. And I'm going to use that to my advantage in this case, but I certainly don't necessarily want to overwrite the front back in this case. So I'm going to call it _T for target. And I've already done this because I was doing some preparation, so I'm going to overwrite that. So now, if I come up here and let's say I'm starting a brand new, I'm going to delete this guy just so we don't get confused. And I'm going to create a brand new picture. If I click this create a picture button, as opposed to hitting one of my favorites, you see I get a list of all these different types of displays that I can make with pre-formatted designs. In case a 2x2 is going to be 4 plots, 2 rows by 2 columns. So I'm going to say create a picture, and up at the top of my list is my newest plot format, and that is called front back _T that I just created. So if I say OK, you see it creates a front back with this data in there already plotted. So now if I go over to my latest run, I'm plotting overall level. Here's my left front ear. And oh no, I'm over target. Let's see if the the right seat did any better. Nope. So immediately after making my measurement, I can plot this versus my target line, in this case, because I created a front back display with that overall level target built right into it, and it made it very, very quick and easy. While I was taking data, I could actually use this display and see these overall levels populate while the data is being acquired in signature acquisition. So this plot with my target line in it could be very, very useful, and I can use it all over the place if I really wanted to. The other option I can do, so if I go up to View, Layout Management, you'll notice I have this front back underscore T appears here, and I can create this as a favorite. I can save it as a favorite. I can also add an icon and have it appear in my favorites list here. So I'm going to say choose a file, and this default directory is where all of these sort of test lab default bitmaps are. In this case, I have one right on my desktop I want to use, and it's Paul McCartney. So I can use any bitmap I want, and I can save that guy. I'll save it. I want to overwrite it, and I want to add it to my favorites. And so I'll add that guy, save it, and I believe he should be in here somewhere. Now I have to add to the favorites. Maybe that's it. Yep, and so now he appears back here at the back. And so now you see this new front back underscore T with a little bitmap icon of Paul McCartney. And now if I click on Paul's face, I get this front back with my target line built right in. So there's a lot of things you can do to use formats that are exactly how you want them over and over. Certainly if I came in here and I changed some things about the basic functionality of the plot, I want to add some grid lines, I want to change the fonts, I always want it to be in real format, etc. I can apply those and then resave that format, and it will always appear exactly that way, including that property schema. So the curve style here, it's going to just use this default, but I can also configure that, load up maybe rainbow here, and then save this, overwrite front back underscore T. And now as data gets dropped in, we will see it will follow that rainbow color scheme. So that's how I can create my own custom layout and actually save it and add it to my favorites. That layout management is also accessible under this little icon over here, but most often I just find myself going to View, Layout Management, and I can configure all of these favorites and build off any one of these random formats. A lot of these defaults are built right in, and I can right click on here and I can switch that front back to a color map, let's say. So I want a color map up here, some front backs. Maybe I want to switch this guy to a numerical down here. So now I'll have a numerical display. So I can do a lot of configuration. All I have to do is save this new layout. If I don't change the name, it's going to overwrite that one that came with Test Lab. So I always like to modify the name just a little bit so that I know it's mine. I might put my initials in there or something and then save it. And then just to make my life more fun, I usually choose a custom bitmap.
Nice, like a super duper layout.
Yeah. And we'll bottom out here with my email address and the community website. If you're doing something else later and you think of a question, please feel free to reach out to me. My email's on the screen. Happy to answer any questions. And I really appreciate your attendance today and hope everyone has a good rest of the day.
Thank you very much, Scott, and thank you everyone for attending.